Hello everyone, welcome to solve this nice exponential equation problem. So if we have 9 to the power of x minus x to the power of 4 equals 65. So we solve this problem for the integer values of x. So here we have one restriction is that our x must belongs to an integer. Okay, so here the very first step we are going to do is here first we rewrite this equation as in this form. So this is 9, we write it as 3 square and its whole power x, minus we write this x to the power of 4 as x square and its whole square equals to 65. Okay, so in the next step here we use the nice exponential law. So according to this exponential law, if we have a to the power of m and its whole power n is equals to a to the power of n and its power of m. It means that if you interchange these two values or these two exponents, then it always gives us the same value. Okay, it means that if you can interchange these two exponents, it cannot be affected our final answer. So here we need to interchange these two exponents and it will be written as 3 to the power of x and its whole square minus here you have x square and its whole square equals to 65. So after this step here we use another nice algebraic formula. So we know about this formula. If we have a square minus b square, it is equals to a minus b times of a plus b. Okay, so according to this algebraic formula, we write our above equation as into the simplified form. So we write it as 3 to the power of x minus x square into 3 to the power of x plus x square equals to 65. Okay, so after this step here you focus in the left hand side and you see that we have two factors are multiplied by each other, but in the right hand side we have only one factor. So now here first we find the possibilities in which the product of two numbers becomes here 65. So that the possibilities in which you get 65 are 1 times of 65 equals to 65 and 65 times of 1 is also 65 and 13 times of 5 becomes 65 and 5 times of 13 is also becomes here 65. Okay, so that we have these four possibilities in which you get the answer is 65. So now if you focus in the left hand side and you see that if you substitute for any values of x, the first factor is always less than the second factor. Okay, it means that if the first factor is always less than the second factor, then here we choose those pair of numbers in which the first number is less than the second number. So if you see here 1 is less than 65, so that we accepted this case, but here you see that 65 is greater than 1, then we rejected this case, and here 13 is also greater than 5, we rejected this case, and 5 is less than 13, so that we accepted this case. So now we divide our given equation into the two cases, so that our first case is in which we compare the left hand side with these two numbers, so that when you compare the left hand side with these numbers, it will be written as 3 to the power of x minus x square is equals to 1, and the second is 3 to the power of x plus x square equals to 65. So now here first we solve this case and we get the values of x, or after that we check is this value is integer or not. So that Now here we add these two equations. So when you add these two equations, then you see that this is the negative and positive value are cancelled by each other. So you get here 2 into 3 to the power of x is equals to 66, because 1 plus 65 becomes 66, and here you have 3 to the power of x is equals to 66 divided by 2. Here 2 is multiplied. When we divide it here, then you get 3 to the power of x equals to 33. Okay, so 3 to the power of x equals to 33. That means uh, here x is not belongs to integer. If you can solve this equation though, so this equation cannot gives us the integer solution. Okay, so from this, if you cannot get the integer solution, then we rejected this case, because here in this question we can solve just for integer values. Okay, so now we move towards our second case. So we write our second case here. In second case, we compare the left hand side with these two numbers 5 and 13. So that we take 3 to the power of x minus x square equals to 5, and 3 to the power of x plus x square equals to 13. Okay, so when you compare these two equations, then you get 3 to the power of x minus x square equals to 5, and 3 to the power of x plus x square equals to 13. So here we add these two equations, and you see that this is negative and positive are gone, and we add these two numbers, then you get 2 into 3 to the power of x equals to 5 plus 13 is 18. Okay, so now we divide this 2 to the right hand side, and it will be written as 3 to the power of x is equals to 18 divided by 2. Then you get 2 9s are 18. So here we easily get 3 to the power of x is equals to 9, and now when we write 9 into the prime factor form, then you get 3 square. It means that we write this 9 as 3 squared, and now we compare both of the sides. Then you easily get the value of x is equals to 2. It means that or also you say that you see that this 2 is belongs to an integer. Okay, so x equals to 2 be the integer solutions of the given equation. And now we check this integer solution. Is this value of x is satisfied our given equation or not? So that to check this solution, here first we need to copy down the given question statement. It is 9 to the power of x minus x to the power of 4 equals to 65, and here we substitute x is equals to 2. So when you substitute x equals to 2 here, it will be written as 9 square minus 2 to the power of 4 equals to 65. Okay, so after this step we have 9 square is equals to 81, and 2 to the power of 4 is equals to 16, and this whole equals to 65. So 81 minus 16 becomes 65 equals to 65. So this shows that the value of x equals to 2 satisfies the given equation. So this is the final answer, and thank you so much for watching this video. Please subscribe to my channel for more exciting videos.